So welcome, guys. In today's session, I'll be discussing antimicrobials, and we'll be discussing the classification of these antimicrobials based on their mechanism of action. Welcome all. My name is Wallace Munyiri, and I'm the Yule Daktari. Let's get to that now. Okay. Now, based on the mechanism of action, these antimicrobials can be classified into the following groups. They can be drugs which inhibit cell wall synthesis. They can also be drugs which inhibit translation, okay, which is protein synthesis. They can also be drugs which affect the cell membrane. They can also be drugs which affect the nucleic acids, your DNA and RNA. They can also be drugs which affect the intermediary metabolism. Now, this session, I'll be focusing on these two, okay? Now, let's get to drugs which inhibit cell wall synthesis. I won't bother you with that because I've summarized all that in this diagram. Now, for you to understand how these drugs which inhibit cell wall synthesis function, you must understand how the cell wall synthesis occurs. Now, I'll try to simplify this as much as possible. Now, this is to the outside of a bacteria from, now let's start here from the bacterial cell membrane. Okay, now that is the outside. Now the cell wall where the cell wall will be found, and this is to the cytoplasm. Okay, now let's start in the cytoplasm, where this is the first reaction where UDP N-acetylglucosamine, okay, UDPG is UDP N-acetylglucosamine is converted to UDP N-acetylmuramic acid by the enzyme enol pyruvate transferase. Okay, then to the UDP N-acetylmuramic acid, you add a pentapeptide unit. Now, that pentapeptide unit contains D-alanine. Okay, now D-alanine is synthesized from L-alanine and ends a reaction catalyzed by the alanine dismiss. Okay, then D-alanine, once formed, they are ligated by the enzyme alanine ligase. Okay, then once that is done, the pentapeptide subunit is added to the UDP N-acetylmuramic acid. Then you have to remove the UDP, and this is carried out by the enzyme bactoprenol BP. And bactoprenol, as you can see, it is attached to the bacterial cell membrane. Then once removed, you form N-acetylmuramic acid, to which a pentapeptide unit is attached. Then to this now unit, you have to attach the N-acetylglucosamine, okay? And you simply remove the UDP from the UDP N-acetylglucosamine and now add that. Now these are the cell wall subunits. These are now the cell like the functional units of the bacterial cell wall. Okay, so all these reactions are occurring in the cytosol. These subunits have to be transported across the bacterial cell membrane so that now they can be assembled to form a functional cell wall. Now, these now functional units of the bacterial cell wall, that is the N-acetylglucosamine, to which it is attached, to which N-acetylmuramic acid is attached to, and now the pentapeptide subunit is attached to the N-acetylmuramic acid. They have to be elongated, to be now attached to each other, and the chain elongation, it is carried out by the enzyme transglycosylase. Okay, transglycosylase, and once elongated, these subunits now, this now chain has to be cross-linked so that now you form a rigid bacterial cell wall, and that cross-linking is carried out by transpeptidase. Okay, now you form a functional, now this is a functional cell wall, which now it consists of alternating subunits of N-acetylglucosamine with N-acetylmuramic acid, to which and the pentapeptide bridges. Okay, now you have understood that is how the cell wall synthesis is done. Now you want to inhibit that. You can do this using various ways. Now, you can inhibit the enzyme enol pyruvate transferase so that the first step is inhibited. And this is the enzyme itself is inhibited by this drug, phosphomycin. Okay. Also, you can inhibit the pentapeptide unit formation. Okay. And this, you can do this by inhibiting the enzymes alanine lesmase and the alanine ligase by the enzyme cycloserine. Okay. Then you can inhibit the removal of UDP from the UDP N-acetylmuramic acid, and also you can also inhibit the transportation of these now functional units of the cell wall across the cell membrane simply by inhibiting bactoplenol. Okay, and you can inhibit bactoplenol by the enzyme, by the compound or the drug bacitracin. Okay. Also, you can inhibit chain elongation by inhibiting the enzyme transglycosidase by using glycopeptides, with vancomycin being the prototype of the glycopeptides. You also have other glycopeptides such as teicoplanin, oritavansin, dalbavancin, teravancin. Now, you can inhibit the cross-linking by inhibiting the transpeptidase. Now, we have one transpeptidase, which is known as the penicillin binding, penicillin binding proteins. Now, penicillin binding proteins are transpeptidases, which are involved in the cross-linking. And this can be done by using beta-lactams. Now, beta-lactams antibiotics include penicillins, okay, your cephalosporins, your monobactams, and your carbapenems. Now, under the penicillins, you have penicillin G, or the benzodiazepine penicillin. You also have your aminopenicillins, your carboxypenicillins, and your uridopenicillins. Okay. Then the cephalosporins, you have the first generation, second generation, third, and fourth. In fact, we have, I've seen some text saying we have fifth generation cephalosporins, such as ceftaroline. Then under the monobactams, you have aztreonam, carbapenems, you have your imipenem, dorepenem, yeah, those. Now, with that, I think you are good. Now, let's go back to here. And let me ask you this question. Which type of action do these drugs? Are they bactericidal or bacteriostatic? Note, all drugs which inhibit the cell wall synthesis are bactericidal. Okay. Now, I think we are done there. Now, you can use this mnemonic if you forget. Remember, these drugs, since they are inhibiting cell wall synthesis, you can say they firmly bind. They bind to the bacterial cell wall. Now, if you are German, you won't say wall, you say wall. Okay, so F phosphomycin, beta-lactams, bacitracin, cycloserine, and vancomycin. Okay. Now, phosphomycin inhibits, its target is the enol pyruvate transferase, beta-lactams, the penicillin binding proteins, the transpeptidase. Then bacitracin, they prevent the phosphorylation of bactoprenol, so they inhibit the bactoprenol. Cycloserine, the alanine resmase and the alanine ligase. Vancomycin with other glycopeptides such as oritavansin, dalbavancin, teicoplanin, they inhibit the enzyme transglycosidase, okay, and they prevent chain elongation. We are done. It was that easy for the cell wall. Now, drugs which inhibit translation of protein synthesis. Now, let's have a recap of how protein synthesis was occurring. In fact, I have a very good video in this YouTube channel of mine on translation. Yeah, you should take your time and maybe watch it. Now, protein synthesis in the bacteria is usually accomplished by the use of a 70S ribosome. Okay. I also have you also need a messenger RNA and a transfer RNA. Now, the 70S will have the 30S and the 50S. Please note, these are not additive values. Okay. So S in this case means the Svedberg unit of sedimentation. Now the 50S subunit has an A site, okay, and a P site, and also an E site, an exit site. Now, when a nascent, or that is an already formed peptide, is usually attached to the P site, okay, then The next amino acid which is carried by a transfer RNA is usually transported to the A site, okay? And the transfer RNA will have a complementing base pair, the anticodon. Now, then a peptide bond will form between the peptide chain, which is now at the P site, with the newly attached amino acid, which is now at the A site, with the help of an enzyme, the peptide transferase, okay? Now, and this, when this is done, now the newly formed peptide chain will be now shifted from the P site now to the A site. Now, for further chain elongation, the A site must be free. So to do this, you have to translocate, so that there must be translocation of the peptide chain from the A site to the P site. Okay, so the ribosome will move one codon forward, okay, so as to expose the next codon, so that now another transfer RNA will come, bind to the A site, and the steps are repeated until now a termination codon is reached, where now protein synthesis stops. Now, let me say this as early as possible, that all drugs inhibiting protein synthesis are bacteriostatics, except for these two: aminoglycosides and streptogamins. Okay, aminoglycosides are your amikacin, okay, amikacin, gentamicin, such drugs. You also have another group of drugs which is related to aminoglycosides, which are known as aminocycritors. Aminocycritors such as your spectinomycin. Now, streptogamins are two, darfopristine, quinipristine. Okay, those are bactericidal, where the others are bacteriostatic. Now, here you can see what happens is that now this is a new amino acid to a transfer RNA. It will come bind to the A site. Once it binds to the A site, a peptide bond will be formed. Okay, and now the new amino acid here, a new peptide chain, sorry, will now be attached to the A site, so that we can continue. This peptide chain must translocate from the A site to the P site. So with now the ribosome will remove one codon ahead, okay, then so that now a new transfer RNA can come and bind to the A site, and the steps are repeated until now a termination codon is reached. Now, we have these drugs you can see here. Now, tetracycline. Tetracycline, what it does, it binds to the A site and prevents a new transfer RNA carrying a new amino acid from binding to it. Okay. Now, chloramphenicol inhibits the enzyme peptide transferase. And okay, then we have another group of drugs which inhibit the translocation from the A site to the P site, and they include macrolides such as your erythromycin, lincosamides such as your clindamycin and lincosamine. Then you have streptogamins, okay, darfopristine, quinipristine. You also have ketolides, okay. Ketolides are like modified macrolides, so they are more resistant to the efflux pumps. Efflux pumps, sorry, they are more resistant to the efflux pumps of the bacteria. So ketolides also have the same mechanism of action. An example of ketolide is erythromycin. So let's look at this. Now, aminoglycosides, they bind to that ribosome. How do they act? 3 ways. They freeze initiation, they interfere with polysome formation, and they also cause misreading of the messenger RNA code. Now, tetracycline and glycylcyclines, okay, they have the same, they also bind to that yes, they inhibit amino acid transfer RNA attachment to the A site, so they prevent it from attaching to the A site. Chloramphenicol binds to the 50S ribosomal subunit, inhibits peptide transferase, and this will result in the inhibition of peptide formation and also the transfer of the peptide chain from the P site to the A site. So remember, if now you cannot form a peptide bond, the peptide chain cannot move from the P site to the A site. Now, macrolides, such as your erythromycin and also lincosamides such as your clindamycin, ketorides, erythromycin, streptogamins, your dalfopristin, quinupristin, bind to the 50S ribosomal subunit. They inhibit translocation of the peptide from the A site to the P site. So you can see where chloramphenicol is inhibiting peptide bond formation and the transfer of the peptide chain from the P site to the A site. Macrolides, concentrate ketorides, and streptogamins do the opposite, the translocation now of the peptide chain from the A site to the B site. Now, linezolid, which belongs to a class of drugs known as oxazolidinones, together with the tedizolid, they bind to the 23S fraction of the 50S ribosomal subunit, and they inhibit initiation by inhibiting the formation of the 70S ribosomal complex. Okay, I think a mnemonic to finish this so that you remember. Now, you yourself are a wise businessman or woman, wherever you are. Now, you should buy things at 30. So buy at 30 and sell them at 50. So at 80 aminoglycosides and tetracyclines, they bind to the 30S ribosomal subunit. Okay, cell, that is streptogamins, then erythromycin. Okay, erythromycin is an example of a macrolide. Okay, lincosamides with clindamycin and lincosamine being examples. Then linezolid, which is falls under the class of drugs oxazolidinones. These bind to the 50S ribosomal subunit. Okay, and by doing so, we are done. And it was that easy. It was that easy. Okay, so asanteni sana, which is thank you very much in Swahili, and follow for more of med content. Thank you.